Hello, everyone. My name is Kaylin Lee from the ICCT, International Council on Clean Transportation. And thank you, Peter and Roel, for your introduction to the policy itself, and then also your specific plans on how to deploy remote sensing technology. Today, I want to take a step back and sort of share our experience at the True Initiative with remote sensing. So the True Initiative, our mission is to support policy actions to improve air quality and mitigate climate change through real-world emissions collected with remote sensing. So we were founded after the Dieselgate in 2015, which revealed the real-world emissions discrepancy in vehicles. And that revelation really highlighted the importance of understanding real-world emissions from vehicles on the road, but also its importance importance of real-world emissions in effective policymaking. So at the True Initiative, we essentially collect remote sensing data and we analyze them, and we also provide technical analysis to policymakers around the world. Here, I show that we have worked with over 20 cities across 5 different continents, and we also supported various policies ranging from low emission zone inspection and maintenance program, and also taxi fleet electrification. So the first role of remote sensing that we've come across in our true work is that remote sensing can play as a monitoring tool for market surveillance, which Ro mentioned briefly before. So as most of you know, remote sensing can measure thousands of vehicle emissions at once, and the bigger the sample is, the more granular the information that you can get. So you can characterize vehicle emission performance by, let's say, Euro standards. If you have more measurements, then you can characterize them by vehicle manufacturer, vehicle models. So the example that I show here is from our remote sensing campaign in Scotland in 4 cities, Edinburgh, Glasgow, Aberdeen, and Dundee in 2021 to 2023. And here I show average NOx emissions of diesel vehicles. First, we see that Euro 5 and 6 who were subject to Dieselgate scandal, they still emit multiple times the type approval limits in real driving conditions, but also newer vehicles like 60 temp and 6D, the standards that introduce additional policy measures to close that real world gap, such as the real driving emissions limit, which I marked in red there. They have the emission performance of different vehicle families vary. So on average, they are emitting below the real driving emissions limit. But if you look into different vehicle families, which are defined by vehicle manufacturer and engine size, there are some vehicle families that consistently perform much worse than the RDE limit. So these are some of the vehicle families that we can flag to the authorities to retest. And that is part of also the EU market surveillance regulation. Remote sensing can also assist in identifying individual high emitters. The earlier example showed high emitting vehicle groups that similar to what we saw in Dieselgate, but as Ro mentioned, remote sensing can help on and off the road. So the table below shows the estimated number of high emitters in different European countries. and they are over like 10%. And then there is a study by the ICCT that shows that around like less than a quarter of high emitters are responsible for over half of the NOx emissions. And this is important because excess emissions from a few high emitters have disproportionately negative impacts on public health. So remote sensing data can be used in different ways to support roadside inspection. So with the wealth of remote sensing data, which represent real-world emissions, we can define high emitter threshold that could be used for roadside inspection. So on the right-hand side is the exercise that we did at the TRU. We used repeated actually truck emissions measurements from the Scotland campaign to define which vehicles are normally behaving and which vehicles are high emitters. So we defined the threshold that Scotland could use if they were to deploy remote sensing permanently and use repeat measurements to flag high emitters. It can also be used as a tool for assisting roadside inspection. Roel already explained, I think, before how that works. So we also did a similar project with Port of Antwerp. That's the picture that's shown below. So we had remote sensing set up around 100 meters before the authorities, and then the remote sensing then would flag potential high emitters, and then the authorities could then check those vehicles. And that increased the detection rate from 2% to 52%. So that's over 20 times. And if remote sensing is deployed permanently, it can act also as a deterrent against tampering. So I think a lot of these high emitters are vehicles that are tampered with or malfunctioning, and especially those that are tampered, these continuous measurement would help them just avoid tampering. And also it can be used as a screening tool for inspection and maintenance program or PTI program, which is also mentioned by Roel. Lastly, remote sensing can also help support the development of targeted interventions or evaluations of existing policies. So the examples that I gave here are city-level policies. So for Warsaw, we did a remote sensing campaign back in 2020, and with the measurements, with over 250,000 measurements that we acquired, we found out that low emission zone will be an effective policy tool for Warsaw because there is a small share of vehicle groups that are emitting disproportionately. So we suggested a low emission zone design, and we also assessed potential emissions impacts using the real world emissions data, which is shown here. And Warsaw has actually implemented the low emission zone regulations since 2024 now. In Brussels, they have a low emission zone in place since 2018. And our campaign was in 2020, I believe. And our measurements showed that still diesel 5 vehicles that are not restricted with the current regulation at the time have disproportionate emission share for NOx and PM. And some of you may know, but last year Brussels had a court challenge actually. They wanted to postpone the next step of the low emission zone that was scheduled for 2025, banning diesel Euro 5. And our analysis showed that diesel Euro 5 actually, despite their small share, they are responsible for 40% of NOx emissions from all passenger cars. So thankfully, they restored, and now the low emission zone is back on track. Another example that I have here is a targeted intervention. So for a policy to be really accepted by the public and also politically feasible, you have to find a way to maximize the impact and minimize the burdens on drivers or vehicle owners. So what we found in 2017 in London was that these black iconic taxis that are all over London, I'm not sure if they're now, so these taxis were emitting much higher NOx emissions than their counterparts of passenger cars. So the year after, the mayor actually phased out the diesel black iconic taxis and promoted the adoption of plug-in hybrids. And we did have an opportunity to look into the plug-in hybrids that London Taxi Company, that's the make of the taxis in London as well, in Scotland. So what we found out from just looking at CO2 emissions of plug-in hybrids is that these plug-in hybrid taxis in Scotland, over nearly 50% of the time, they were actually not running on batteries. They were emitting emissions, while the type approval information shows that their electric share should be around 90%. So these are some additional policy evaluation that we were able to do using the wealth of emissions data that we have over the years. And this, everything highlights the fact that remote sensing can be used to also develop a policy action, but if it's deployed continuously, it can be used to assess those policies and refine and monitor. So it closes that policy-making cycle. I think that's my last slide. Thank you for your attention.